is a 6th grade standard is because of the first line that's going to be in your packet. Where's the first line say? In other words, you've already what? You've already learned it because it says recall. You can't recall something that you haven't already seen and learned. Can't. Not possible. So, somewhere in the 6th grade, you learned this. Or, in the 6th grade, you also weren't paying attention, and you missed it. But I'm going to tell you, it's not difficult. If you try to go strictly by the examples that are in this packet, you're going to get confused. I recommend that when I get the Khan Academy video out, which I'm going to do momentarily, I'm going to put a Khan Academy video up here, that you have a sheet of paper out and you write down his examples, because his examples are going to be easy to follow, they're going to be easy to take notes on, and on top of it, when you go home, all you've got to do is type in mean absolute deviation into a search engine, and the first thing that's going to show up is what? Khan Academy's video. By the way, the other thing that you could pull up is my web page. Because what's going to be on it? The video. Because it's recording everything that I put over here on the screen. And in a minute, Khan Academy is going to be over here and it'll record it. So you can get it from either place. Mean absolute deviation is called MAD. Recall to find the mean absolute deviation of a data set. First you find what? The mean of the data. That's the first thing you're going to find, is the mean of the data set. If you look at that first example that they gave you, how many points does it say in the minutes per day exercise? How many pieces of data did they give you? Was there 12? 12 or 13 points, 12 points there? And in the minutes per day planning video, there's 2, 4, 6, 8, 10, 12 points there as well. It's silly to have you practice this with that many points. It's silly to teach it that way. I need to teach it on a smaller term where you can understand it. It's okay to practice 1 or 2 that have big data sets, but it's silly to sit there and make you go through that many things. It says we're going to find the mean. Remember, that means you add up all the pieces and you divide by the number of pieces that there were. Take the absolute value of the difference. And absolute value means what? That your result is always going to be positive. Absolute value means the distance from 0. Distance is a positive number. So the absolute value of a -5 is 5. The absolute value of 5 is 5. The absolute value of a -2 is 2. The absolute value of a +2 is 2. Anything that is on the inside will come out as a positive. The word difference means that I'm going to subtract. I'm going to take the mean and I'm going to subtract the original piece of data. I'm going to find the difference. In other words, how far is each piece of data away from the mean? How far it is away from the average. Make sense? And it says, finally, you're going to find the mean of those absolute values. So you're creating a whole new data set, and then you're going to find a brand new mean. And the mean that you find is going to be called the what? It's going to be called the MAD, or the MAD. Okay? All of that on the very front page of the packet. The next piece that you're going to see, the Khan Academy video, not on the packet. That you need to have a sheet of paper out for, because here it is.
So let's say that I've got two different data sets. So the first data set, I have 2, another 2, a 4, and a 4. And then in the other data set, I have a 1. I'm going to do this on the right side of the screen. A 1, a 1, a 6, and a 4. Now the first thing I want to think about is, well, is there a number that can give me a measure of a measure of center of each of these data sets? And one of the ways that we know how to do that is by finding the mean. So let's figure out the mean of each of these data sets. So this first data set, the mean, well, we just need to sum up all of the numbers. So it's going to be 2 plus 2 plus 4 plus 4, and then we're going to divide by the number of numbers that we have. So we have 1, 2, 3, 4 numbers, so that's that 4 right over there. And this is going to be 2 plus 2 is 4, plus 4 is 8, plus 4 is 12. So it's going to be 12 over 4, which is equal to 3.
Okay. He started out with 2 data sets. And he said the first thing we're going to find from each of the data sets is what? The mean. What is that? 3. That's the mean. Everybody need a second to write it down? Are we good?
So actually, let's see if we can visualize this a little bit on a number line. So actually, I'll do a little bit of a dot plot here, so we can see all of the values. So this is 0, 1, 2, 3, 4, and 5. And so we have 2 2's. And so why don't I just do, so for each of these 2's, actually, I'll just do it in yellow. So I have 1 2, and then I'll have another 2. I'm just going to do a dot plot here. And then I have 2 4's. So 1 4, and another 4 right over there. And we calculated that the mean is 3. The mean is 3. A measure of central tendency, it is 3. So I'll just put 3 right over here. I'll just mark it with that dotted line. That's where the mean is. All right, well, we've visualized that a little bit, and that does look like it's the center. It's a pretty, it makes sense. And also look at this other data set right over here. So the mean over here is going to be equal to 1 plus 1 plus 6 plus 4. All of that over, we still have 4 data points. And this is 2 plus 6 is 8, plus 4 is 12. 12 divided by 4, this is also 3. So this also has the same mean. We have different numbers, but we have the same mean. But there's something about this data set that feels a little bit different about this. And let's visualize it to see if we can see a difference. Let's see.
Everybody have the mean from the second data set? Oh, yeah. I'll give you a second. What do you think he's going to put underneath it? Another dot plot. He's going to put another dot plot underneath there so that we can see that this mean, this central tendency, the center, we can look at it and see whether it looks like it's a center or not. Okay? Am I good?
We can visualize it. So I have to go all the way up to 6. So it says this is 0, 1, 2, 3, 4, 5, 6. And I'll go 1 more. 7. So we have a 1. We have a 1. We have another 1. We have a 6. And then we have a 4. And we calculated that the mean is 3. calculated that the mean is 3. So the mean is 3. So when we measure it by the mean, the central point or measure of that central point, which we use as the mean, well, it looks the same, but the data sets look different. And how do they look different? Well,
Okay. So before he answers that, how do they look different?
This one doesn't really look in the central as that one.
Why?
Because this one is more spread out from the range is not there.
It's not. It's further distance away from what? The mean.
More numbers on the green one and this.
There's the same amount of numbers. There's 4 numbers on each, right? Yep.
The dotting of 4 is how the way the dot plot is.
But what about it? That's what he's asking. Take a look at it, and what really sets these two apart? What makes them so different?
On the first one, it is actually between the two,
Mm-hmm.
because they're closer together. But on the other one, it's kind of not in between all of them.
Okay, it is between all of them, but what happened?
The first dot plot has 2 on each, but, well, they have the same mean, but the difference between them is the data is not the same between each other or relevant to each other.
What?
Range.
The range is different, yes. How far is it from the mean to each one of these points? How far is it from the mean to each one of these points? Okay, so on this one it depends, doesn't it? Okay. I just want you to be able to see that, so when he starts with the next piece, you're making the connection of why we would want to look at a map.
we talked about notions of variability or variation. And it looks like this data set is more spread out. It looks like the data points are more, on average, further away from the mean than these data points are. And so that's an interesting question that we ask ourselves in statistics. We just don't want a measure of center, like the mean. We might also want a measure of variability. And one of the more straightforward ways to think about variability is, well, on average, how far are each of the data points from the mean? And that might sound a little complicated, but we're gonna figure out what that means in a second, and not to overuse the word mean. So we want to figure out, on average, how far are each of these data points from the mean. And what we're about to calculate, this is called mean absolute deviation. Absolute deviation. Mean absolute deviation, or if you just use the acronym MAD, MAD, for mean absolute deviation. And all we're talking about, we're going to figure out how much do each of these points, their distance, so absolute deviation, how much do they deviate from the mean with the absolute of it. So each of these points at 2, they are 1 away from the mean. Doesn't matter if they're less or more, they're 1 away from the mean. And then we find the mean of all of the deviations. So what does that mean? I'm using the word mean. Well, I'm using it a little bit too much. So let's figure out the mean absolute deviation of this first data set. So we've been able to figure out what the mean is. The mean is 3. So we take each of the data points and we figure out what's its absolute deviation from the mean. So we take the first 2. So we say 2 minus the mean. 2 minus the mean, and we take the absolute value. So that's its absolute deviation. Then we have another 2. So we find that's absolute deviation from 3. Remember, if we're just taking 2 minus 3, taking the absolute value, that's just saying it's absolute deviation. How far is it from 3? It's pretty easy to calculate in this case. Then we have a 4 and another 4. So let me write that. So then we have the mean, or we have the absolute deviation of 4 from 3, from the mean. And then plus, we have another 4. We have this other 4 right up here. 4 minus 3. We take the absolute value, because once again, it's absolute deviation. And then we divide it. And then we divide it by the number of data points we have. So what is this going to be? 2 minus 3 is...
Here's what I want you to notice. This was the original data set. 2, 2, 4, and 4. Technically, what he's doing is he's creating a brand new set of data. He's creating a data set that shows the distance it is away from the mean. This 2 minus 3 is what? It's actually a negative 1, but the absolute value becomes... So this piece of data is a 1. 2 minus a negative 3 is negative 1, but the absolute value is positive 1. So that's in the data, 1. 4 minus 3 is 1, so the absolute value is 1. And 4 minus 3 is 1, so the absolute value is 1. So the 4 new pieces of data are 1, 1, 1, and 1. And he's finding the mean. In other words, he's averaging those 4 new pieces of data together to find the mean absolute deviation. Okay? That's what we're doing.
Negative 1, but we take the absolute value, it's just going to be 1. 2 minus 3 is negative 1, we take the absolute value, it's just going to be 1. And you see that here visually, this point is just 1 away. It's just 1 away from 3. This point is just 1 away from 3. 4 minus 3 is 1, absolute value of that is 1. This point is just 1 away from 3. 4 minus 3, absolute value, that's another 1. So you see in this case, every data point was exactly 1 away from the mean. And we took the absolute value so that we don't have negative ones here. We just care how far it is in absolute terms. So you have 4 data points. Each of their absolute deviations is 4 away. So the mean of the absolute deviations are 1 plus 1 plus 1 plus 1, which is 4 over 4. So it's equal to 1. So one way to think about it is saying, on average, the mean of the distances of these points away from the actual mean is 1. And that makes sense because all of these are exactly 1 away from the mean.
Okay. Now, the MAD is what? 1. If I'm looking in a measure of central tendency, okay, what would I want my MAD to be? Would I want it to be really large, or would I want it to be really small? Small. Because the closer it is to 0, then the closer all the numbers are to the mean. They'll be less spread out. It'll give me a better idea where that mean actually fell in my data set. Everybody good? We're good to this point.
Now let's see what results we get for this data set right over here. And I'll do it. Let me actually get some space over here. At any point, if you get inspired, I encourage you to calculate the mean absolute deviation on your own. So let's calculate it. So the mean absolute deviation here, I'll write MAD, is going to be equal to, well, let's figure out the absolute deviation of each of these points from the mean. So it's the absolute value of 1 minus 3, that's this first one, plus the absolute deviation, so 1 minus 3, that's the second one, and then plus the absolute value of 6 minus 3, that's the sixth, and then we have the 4, plus the absolute value of 4 minus 3, and then we have 4 points. So 1 minus 3 is negative 2, absolute value is 2, and we see that here. This is 2 away from 3. We just care about absolute deviation. We don't care if it's to the left or to the right. And we have another 1 minus 3 is negative 2, it's absolute value, so this is 2. And that's this. This is 2 away from the mean. And we have 6 minus 3, absolute value of that's just going to be 3. And that's this right over here. We see this 6 is 3 to the right of the mean. We don't care whether it's to the right or the left. And then 4 minus 3. 4 minus 3 is 1, absolute value is 1. We see that. It is 1 to the right of 3. And so what do we have? We have 2 plus 2 is 4, plus 3 is 7, plus 1 is 8 over 4, which is equal to 2. So the mean absolute deviation, let me write down, it fell off over here. Here for this data set, the mean absolute deviation is equal to 2, while for this data set, the mean absolute deviation is equal to 1.
Good?
Is that all when they ask for this type of question, that all the answer would have to give them 1 and 2?
Yes, if they ask for the math, what are you going to do? Your number is going to be a single what? Number. But you're going to have to calculate it. How did we calculate it? Well, you found the mean of the original data set. You found the difference between the mean and each piece of data, and you took it as an absolute value. In other words, the distance each one of the pieces of data were from the mean. And you found that new average.
So do we really have to draw the line?
No, he did this as a visual point of view, so that you could see that in this data set, each one of them actually came out how far away from the mean? 1. And in this one, each one of them came out what? 2 away. Which of the 2 data sets, the first one or the second one, is the 3, the mean, a better measure of central tendency? Number 1 is a better measure of central tendency. But the MAD tells me how far each one of my pieces of data are expected to be away from that measure of central tendency. So it gives me another way to look at it. If I knew my mean was 50 in the classroom on a test score, but my MAD was 25, it tells me that everybody on average was 25 points on one side or the other of the 50 on average. That would be pretty big, wouldn't it? In a classroom, I'd want that MAD to probably be around 10%. That makes sense to everybody?
And that makes sense. They have the exact same means. They both have a mean of 3, but this one is more spread out. The one on the right is more spread out because on average, each of these points are 2 away from 3, while on average, each of these points are 1 away from 3. The means of the absolute deviations on this one is 1. The means of the absolute deviations on this one is 2. So the green one is more spread out from the mean.
Oh, I like this lesson. It's very common. It is common.
Listen, for homework, it's going to seem like it's very little amount of work. But they may take you a few minutes to do. Okay? I want you to do page 350. I want you to do number 1, where they ask you what is the mean, and they ask you what is the MAD.
So the first one.
So for problem number 1, you're going to find both the mean, which is the average of the original data set, and then you're going to find the MAD, the mean absolute deviation. So you're going to find out the average of how far each one of those points are away from the mean. Okay? And then on page 351, I want you to do number 5, which says what is the mean and what is the MAD. Those are the only 2 questions I want you to do. Number 1 and number 5.